Thank you for the introduction, Callum. So today I'm talking about using PromQL for custom data sources. We've already had a couple of great talks about PromQL and queries this morning. This is looking a bit more at the other side of instead of improving samples and that, we're actually going to look at how we can get data back from any sort of data source you want and put it in a format that is available for PromQL to query. So first off, a bit about me. I'm a Prometheus maintainer for about 3 years now, mainly focusing on remote write. So the query side of Prometheus is a bit newer for me, and I had a lot of fun learning about it. I'm also working at Grafana Labs on some of our machine learning projects. And when I'm not at my desk, you can find me out in the mountains of my home doing skiing, hopefully very soon again, climbing, hiking, things like that. So what are some of the problems and motivation that I have for using PromQL? Like at least 2 of you that I heard this morning, I enjoy PromQL. I'm also very familiar with it. I use it every single day for running all of our systems. And I want to use it to also explore data in other systems. I'll show a quick demo in a little bit where I can look at some of my Strava activity data with PromQL and just explore different visualizations that way. We also, as part of the machine learning team, we wanted the ability to use PromQL to actually query predictions into the future, very similar to what Andrew at GitLab was doing yesterday. We want to be able to display that data with PromQL. And we just found a lack of customizability in how we were managing to get data into existing Prometheus, into Mimir, into Thanos, anything like that. And finally, some of my motivation is just for fun and learning. I like playing around with new tech, and maybe there's cool things that you all want to visualize with PromQL as well. So just a little bit about what are the sources of data that you can use to query with Prometheus today. First is the most common, direct instrumentation or an exporter. Prometheus comes along, scrapes that data. It works for almost all of Prometheus's core use cases. But you can actually also do custom data with remote read. Remote read is typically used to retrieve data that was remote written to an external system for long-term storage or something like that. But you don't need to do that first. You can just implement a remote read server that returns whatever you want. And that can be used to do very interesting things like provide data that is then used in joins, have custom data, things like that. But there's some downsides there. For one, it doesn't support the really nice autocomplete features that require the label names and label values support. And it also still requires a Prometheus instance to be running, which for something like my Strava data, I don't really need that in Prometheus at all. So an idea I started experimenting with was actually just creating a dedicated service that still uses the Prometheus API and the Prometheus code base, but plugs in a different backend for the storage of whatever you want it to be. So just a very brief look at what that is you can still use Grafana, the Prometheus UI, whatever you want. That will be connected to just a custom PromQL server, and that will query your backend data source. In this case, I will show a quick example of a Strava data. So let's exit out of that. Make that a bit bigger. So here's just a running local Grafana instance. All I've got in it is a Prometheus data source that I've called StravaQL. I can hop over to Explore and look at the different metrics that I've implemented so far. So here's a few of them. Let's take a look at Strava elevation gain meters total, so how much elevation I'm climbing. And let's look at that across just a week. So how much elevation am I climbing in a week over the last year? Cool. Wait a few seconds and you get a response back. So this is what an example response from my little Strava demo is. It splits it up by the different sports that Strava allows. You can see I did a lot of climbing kind of last spring and winter, but that's actually alpine skiing, so That's really just riding a lift. It's not that interesting. So let's actually filter that all out. As you can see, type ahead working as you would expect. And here you are with the remaining. We could maybe sum across that and get an idea of, and I can just really quickly analyze how my training, how my activities are going. I think this is a little interesting because not climbing a whole lot during the colder months, and then as all the snow melted out in Colorado where I live, really got into those higher peaks and doing more adventures over the summer. So that's just kind of interesting to see for me. You can also do some interesting things with like offset queries, where I can suddenly compare last year to this year and how much I've been doing activities this year versus last year. So like this summer, greens this year, yellows last year. I was struggling with some injuries, not quite as much volume, but started doing better and have caught up recently. It's just kind of fun things to track. So that's a quick little demo. And then, so how can you do this? How can you do this for your data? It's really not that hard, and it was really fun to see just how far these interfaces have come along, that you can implement whatever storage querier interfaces you want, and that you have to implement that. You have to implement some iterators that I'll go over pretty shortly, and then you just need to create a server using v1.newAPI call in Prometheus. That call does take about 15 different arguments, but most of them can just be nil or little dummies. I basically copy and paste it from somewhere each time I create a new one. So let's start with how do you actually create these queriers? Something interesting about the PromQL API is you actually create a new querier for every single request. And the querier gets created from a few different things: a context, and a min time and a max time for your query, so you know what sort of data ranges you need to be fetching data for. And it also gives you a great time to inject any sort of custom components you want, so like a Strava client, gRPC clients, anything like that. And the context gives you an opportunity to put in values for, say, a customer tenant or different request headers, something like that that is request specific with a middleware. Once you have a querier, you need to implement these 4 functions on that querier at a minimum. So we've got select, which is doing the core of the work, and that is actually pulling the data, the samples back and transforming them into series. And we'll go further into that soon. And then there's label names and label values implementations that I mentioned. You can just return nil, nil, nil for each of them, but I really like having type ahead, so having at least some knowledge in each of those is super helpful. And close is self-explanatory. It cleans up resources when you're done. So let's take a look a bit more at select. So this is kind of a common pattern I have found when I've been making these custom PromQL servers, is that I will take select, and it comes with matchers. And the first thing I've commonly done is just parsing out the name and requiring a metric name to be set. Prometheus doesn't strictly need a metric name in every query, which is very powerful, but a lot of other backend data sources, you'd be just fetching far, far too much data if you tried to effectively do a select everything. So I'll commonly require a metric name, and if one isn't present, you can return an error series set, which will return a 422. I believe that's unprocessable entity to the user. And it also means you probably shouldn't use an error series set for something like a intermittent 500 that gets returned. The best way I've found to handle that is actually to panic and then recover the panic in a middleware to return a 500 from PromQL. So once you get a metric name, I'll usually split up and look and do different logic for each case. So the quick Strava sample is for something like Strava activities total. I just need to fetch all the activities for a user for the given interval and matchers. But for something like moving duration, I actually have to I have to sum up all of the different times I've spent on each of those activities. And then finally, in the case that nothing matched, you can imagine maybe this is also a map or something like that, you can return an empty series set that is also implemented for us. And that's really useful to keep the same behavior in Prometheus, where if you put in a query that doesn't return a result, you don't get an error back from Prometheus, you just get no results. So empty series set, very helpful. So let's take a bit more of a look into what the, first off, select hints. These are really actually quite useful that I didn't show on the last slide, but it allows you some really fine-tuned control over making queries correct or more efficient. So these select hints also come in for every select, and they contain things like the start and end if they're different from the overall query, as well as the step, which can be used for how frequently you need to look at data. The function, is this a rate or an increase or an average over time? You might want to aggregate your data differently for each of those. So this is just a really good thing to know about. And then finally, here we have what a series set looks like. So you saw we're just returning series sets from select, and they're iterators across series, which are just defined as a label set and another iterator of samples. And you'll see that as a common pattern where all of these are iterators. So here is also the iterator for samples. We'll take a look at this a little bit more in detail, but some things to notice is we have both next and seek, which you're only ever having to look forward in time, which is nice. And then the at function, is just returning a sample timestamp and a sample value. It's kind of a lot to implement though, and Prometheus comes with yet another helper function, which is this new list series iterator, which allows you to just create a slice of samples and return that, and it does all of the iterator logic for you, which for these examples like Strava is much easier than implementing the iterator I found. So here's the code that I have from that low Strava sample, and this is also on my GitHub, so I'll have a link at the end. But what I'm doing is looking across all the timestamps in my select statement, and then finding all of the activities that are before that timestamp, counting them up, and for each timestamp appending that value. And we just go through for each timestamp, do that, and that's really how all of those were implemented. But instead of ++, I might do += for every single activity's moving duration or something like that. But there are times where you want to go back, I'll just go back to this chunk iterator side, where you do actually want to completely implement this iterator. And those are things where you could say need to fetch a lot of data back from remote storage. You might want to do that in a lazy way, or it might be too memory intensive to store all of the external systems data in one place. At that point, this next and these seek calls are very important, and you can get some good performance improvements by actually implementing the iterator. And then just kind of some final notes of different gotchas that I've found if you are going and creating your own PromQL data sources. So the first one is staleness handling. Just kind of curious, how many of you have ran across staleness issues in Prometheus before? At least, honestly, like 10%. That's more than I expected. So by default, Prometheus will look back over the last 5 minutes and only the last 5 minutes for any samples. For Prometheus use cases that are scraping every 15 seconds to maybe every 1 minute, that works really well. But if I'm pulling data back from a system that only reports data once an hour, unless your query happened to align to the timestamp within 5 minutes of that hour resolution, you just end up with no data back. So you have a couple options there. You either have to align all of that sparse data to your query, or you have to create some sort of interpolation so that you return at least a data point every 5 minutes, maybe even more frequently than that, depending on the functions being used for your queries. And you also will want to keep in mind that stale nan, there's a specific not a number value that exists in Prometheus that will mark the end of a series. And if you're pulling data back from an external system, that system's not going to know about this, and if you know a series ended, be sure to inject that stale nan yourself. And then it's very common to have just some sort of caching layer in addition. So that's something like, for the Strava example, I'm very likely to change data over the last week. I might be on a backpacking trip and just uploaded my activities a week later. And this is one of the reasons I can't just write a Strava exporter that returns all of the data at time right now is, well, that activity I did 3 days ago, I wanted those metrics from 3 days ago instead. But I don't want to have to refetch every activity from the beginning of time in Strava. So in that case, maybe caching data starting a month ago would make a lot of sense. And then finally, one other thing I really like about these custom PromQL servers I've written is that I can try out new query improvements, new features. The Thanos query engine is actually something I've been trying out on the one of these I've written at Grafana to get some really nice query improvements for our customers. So those are just some other cool things that you get to test out by doing some custom PromQL servers. And that's all that I have a presentation for. You can find the code for this Strava server and GitHub, and any questions.
So cool. On the staleness handling for sparse data, I mean, you're probably aware of the look-back delta that you can set, but was it not what you were looking for there? Like in the PromQL engine, you can just configure the look-back delta to be arbitrarily large.
Yes, so that is, I can hop over to that actually, I believe. So you can configure the query lookback delta kind of based on your system. And that is one option that you can do, unless it changes depending on the query. That is a value for the entire server, and you can't customize it per query. So sometimes I still had to align things manually or interpolate. But good point. You could create a new engine every time, but when you actually go to define, like, you'd have to create a new API every time, I think.
Yeah. Any other questions?
You said sometimes you have to reconstruct a counter from incremental data. Say you walked 500 miles and then you walked 500 more. How do you safely set like a starting point for that counter?
Yes, so that is a great question. There are kind of two ways to do that. In my super basic Strava, I just set it at the beginning of time each time. But that is something you can do with the query hints. If you know that you're putting in that this is going to be surrounded by a rate or an increase, you would only have to construct that counter from the beginning of basically the query min time. And that's a great optimization rather than having to, I mean, I think I have 6 years of data in Strava right now. I might only have to fetch a year of data instead of 6 years if I know it happens to be surrounded by an increase.
Anyone else? Going once, twice? No? Okay, cool. Thank you, Chris.
Yeah. Thank you, everyone.